everyone. So today's lecture of building services is on electrical installation from its generation to distribution. So before the electricity reaches our house, there are several steps through which the electricity passes from the source of generation to our houses or to our buildings. And it is important to study the installation because it will help us in planning the electrical design, the electrical circuit inside our building, and it will also help us in designing the outlets like your sockets, your switches, your fixtures. So before learning about the switches and sockets and every final outlet in a building, we should know what is the source of it and how is it coming to our place step by step. It will also help us in ensuring the safety of our buildings because it's always an option to produce our own electricity, but if we are doing it at our own scale, it can be risky sometimes. Using solar panels and windmills, which are from your natural resources, is completely fine. But if we think about generating our electricity from coal, from thermal resources or from nuclear resources, that is completely impossible because it will obviously be not safe and it requires proper facilities and equipments to work on. So safety is the first point, then is efficiency. Okay, let's say it's all safe and people are producing their own electricity, but it's quite possible that the energy produced is not efficient, which means there can be a lot of loss of electricity while producing it. So we might be losing much of electricity rather than generating that amount of electricity, and that will ultimately just lead to loss, financial and electrical both. So the first step, let me tell you about the steps first. The very first step is generation, which is done in our power plants. Then after generation comes step up transformer, then we have transmission lines, then we have step down transformer, then at last we have distribution. Let's start with generation first. We have these factories which are called power plants, in which power is generated, and in these power plants our mechanical energy is actually converted in electrical energy. Now we have different types of power plants with which we can generate electricity. The first type of power plant is known as thermal power plant. In thermal power plant, the basis that we use, it can be coal. We can burn coal or gas or oil, which is used to produce steam, and this steam helps in running the turbines connected to the generators, and that is how the energy is generated in thermal power plant. We are using these resources like coal and oil. We are producing steam with the help of it. So this is the type of power plant that is most common globally, but its negative point is that it has very high carbon emission, because when we are burning coal, gas or oil, it will obviously produce gas pollution and it will harm our environment. Second type of power plant is our hydropower plant, or also known as hydroelectric power plant. Now in this we are using water, and with the help of water we spin the turbines again, and in this we are converting our kinetic energy into electrical energy. Now what happens in a hydroelectric plant? You normally have a dam, or you call it a reservoir, and you store the water on one side and you have outlets this area. So when the water flows, with the help of gravity, we have a lot of pressure in our water. When it comes down with so much high intensity, we have little turbines. We have turbines in our dams which on which this water falls, and with the help of this, these turbines just spin, and with the help of this spinning, our energy is produced. So the positive point of this hydroelectric plant is that it is renewable because we are using water. It's a very clean process. We don't get any pollution or harmful gases out of these power plants. But the negative, or we can say a constraint about a hydroelectric power plant, is the availability of water. So that is why it's generally made where we have big water bodies, and try to use the areas which have hills or slopes, because the gravitation will help the water to get on the turbines and make them spin. We don't have to use extra pumps so as to pull the water up and then throw it from some level. In the hills, we automatically get this with the help of gravitational force, and without using the pumps, we are actually saving energy and a lot of money. So, a constraint about this is we need hills plus we need water. But the positive point is it is renewable, it's clean, and it hardly produces much of pollution. Now, third type of power plant is our nuclear power plant. In nuclear power plant, we use nuclear fissions, which are your reactions to your elements. We take 2 to 3 elements, we fuse them together, and then with these, a lot of radioactive waves are produced, and this heat which is generated by the chemical reaction of these elements, it is again used to produce the steam. And with the help of these steams, we are again running turbines, and these turbines are converting the nuclear energy into electrical energy. This type of power plant uh, should be used at a very minimal scale, because it has so many radiations coming out of it, since we are using these elements, and it will create fumes all around the air, the nearby areas, and there is a very high energy input that we require in these power plants. These radioactive waves that are produced, it is not good for human beings, for plants, everything that is living, it's not good for them. So that is why these must be avoided in most of the cases. But in certain areas where you don't have any option for making a dam, or you don't have raw materials like coal and gas to burn out and produce electricity, in that case you'll only be left with the option of renewable power plants. So yeah, it's a choice, but it should be avoided. Then the last is renewable energy resources. It includes all the power plants that run on renewable resources like sun, wind. So with the help of sun, we can use solar panels. And these solar panels can be used to produce electricity in our houses. With the help of wind, we can use windmills, or also known as wind turbines. So these can help in generating electricity. Again, this wind turbine, with the help of wind, high velocity winds, this will move, and this moving turbine will create energy. Then we also have geothermal power plants. They can also help in creating electricity. Now, all these types of power plants, they are using sustainable raw materials so as to produce energy. And in today's world, in 21st century, we always try to promote solar panels and turbines wherever possible, because this will help in promoting green architecture and harming the nature as less as possible, and it will help us lead a sustainable life. Now, the very first step was generation, in which we are generating electricity. These can be called as power plants. The second step is step up transformer. Now, in our power plants, the electricity which is generated, it is relatively of low voltage, from around 11 to 25 kilovolt. so that we can transmit it through wires efficiently over long distances. We'll step up and increase the voltage from this kilovolt to 220 to 400 kilovolts. Now we know that in our power plants we are generating electricity at much lower voltage so that it is easy for us to transport this electricity over long distances. Once the electricity has traveled through your area, the electricity will go to your step up transformer, and the step up transformer will change the low voltage to high voltage. Now in our step up transformer we have a core something like this, and primary core is the core which is taking the voltage directly produced by your solar power plant, and like we said it is around 11 to 25 kilovolts. With this core, what we are doing, we are increasing the amplitude of this electricity, and from 100 to 25 kilovolt we'll change it to 200 to 400 kilovolts. The number of turns in the wire of our core will increase, because if we have less voltage will require a smaller area so as to travel. But if the voltage is increased, the length of our wire will also increase, because this small length of wire will catch up heat. It will overload if we pass the same amount of current through this length of wire. So since we are increasing the size of our wire, in the secondary core the number of turns will increase so as to carry more of voltage. So this is now from this level, when we have stepped up our electricity, we'll transmit this electricity through antennas towards our main city, and then it will be distributed to residential areas, to commercial areas separately after sending them to step down transformer. So the next step becomes transmission lines. So after this, the electricity will be transmitted through big antennas to our step down transformers. So these wires are actually very high transmission wires, and we generally place these wires in open areas or agriculture lands so that it's not overhead for the people. Since it carries waves and it is harmful for the human beings. So transmission lines, these lines are also called as high voltage lines, and they are used to carry the current or transmit the electric current from source to the center. Now, these transmission lines are generally of two types. The first types are our overhead lines. These are the lines which I'm talking about, the power grid lines. These are the lines which go overhead, and they are generally made up of aluminium or steel, and they are generally cheaper in cost. That is why in underdeveloped cities you will always see the antennas overhead. And the second type of antennas are underground cables. In these, the high voltage cables are buried below the ground, and there is a proper conduit running throughout your roads, which is actually carrying up your wires of electricity. So these are made up of high quality insulated materials. That's why they are expensive. But the positive point about it is very safe since it's underground. So the electric shortage or overloads, we have several areas which are used for servicing the wires time to time, and even it looks aesthetically beautiful and it does not destroy the beauty of your cities. On the other hand, the overhead lines, they are not safe. You can get short circuits. Even the regular wear and tear due to atmosphere can affect the lines and your transmission meters. So overall this is cheaper, but not preferred, and it will obviously depend on the budget of the government, which option to take. Now, the next step after transmission of your electricity is your step down transformer. Now, what happens in step down transformer? The same core that we studied earlier, the same core is there, and then from 400 to 300 volts, we can reduce down our voltage to 200 volts or 300 volts or maybe 100 volts, depending on the type of building that we are going to take the electricity in. For example, for houses, we only need 240 volts. For industries, we can have around 350 to 400 volts, and for other commercial areas, maybe 200 to 300 volts. So let me give you an example of step down transformer. If you have a campus or maybe a township, you might have seen there is a small building block which is called as electrical substation is installed in your areas. Either it's your campus or it's a public building. What happens there is, suppose you are studying in a university and your complete university needs electricity, you will have one electrical substation installed in your site, which is taking the electricity from these transmission lines inside their campus. So this is where the step down transformer will be installed, and this step down transformer will convert your voltage into the voltage that is required by your premises. So this is how it helps, and it reduces the voltage as desired. It is easy to manage the local distribution after it is coming in your electrical substation for stepping it down, because after this substation there will be a distribution of two types, which comes under our next step, which is called distribution. Now, distribution is of two types. One is primary distribution and second is secondary distribution. The primary distribution refers to the distribution that is sent to our industries, because in the industries we need more of electricity, more higher voltage of electricity as compared to our houses, residential properties or commercial properties. Houses will mostly need 240 volt at max. That is why these phases are divided into two parts, so that according to the usage of the area, the electricity can be further distributed. And at last, the electricity reaches your building services through your electrical poles. So everyone might have seen small electrical poles installed outside on the road outside your houses. So these are the poles that are actually taking in electricity inside your building, and through the cable service and the speed transformer that you'll have for stepping down your electricity, you'll get the electricity inside your building. And how is this electricity taken in the building? You might have heard about meter, which is in technical terms called as distribution board. This is the board that further sends your electricity to your different sockets, to your different floors, to your different areas where it has to be used. Board is the board which records your consumption of building. So yeah, this was the whole process, how the electricity goes inside your building. The very first, let's just take a quick recap. So the very first step is generation in your power plants. After the generation, the electricity is stepped up so as the transmission can happen smoothly. The transmission lines carry the current through themselves, which take the current to your step down transformer, and the step down transformer is installed in your local electrical substation. Now this electrical substation is different for houses, different for industries, and different for commercial areas, because the amount of electricity, the voltage of electricity that we require in a particular building will be set down to a particular value in this electrical substation only. After the electrical substation, you will have the distribution. After the substation, you'll have the distribution inside your buildings through the electrical poles. And if you have to take the electricity to the industries, it has the major electrical three phase electricity, which comes in your primary distribution. Secondary distribution are the relatively lower voltage distribution, which generally comes to our houses. And in houses, the electricity is sent through electrical pole to our distribution board, which is also called MCB or meter, which is used to calculate or record the consumption of electricity inside our building. So further, how the electricity goes inside the building, that will be our next lecture. Through distribution board, we have wires and cables that lead to sockets and switches, how they all work, how many types of switches are there, how many types of sockets are there. So that will be our